So we've talked about the urinary system anatomy, and I'm just going to hit on about fluid and electrolyte balance. So, urinary system, a moderately full bladder is about 500 milliliters of urine. It is capable of holding about twice that much. Fluid and electrolyte balance then, blood composition depends on three factors: diet, cellular metabolism, urine output, and the constituents of that urine output. Now, kidneys have four roles in maintaining blood composition. First off, we get rid of nitrogenous waste, and we've previously discussed these as waste products that come from metabolic processes, such as breaking down, building up amino acids into proteins, etc. It's important in maintaining water balance in the blood, keeping the appropriate amount of fluid in our bodies, maintaining electrolyte balance of the blood, and ensuring proper blood pH. Now, normal water balance. Normal amount of water in the human body, in a young adult female, it's about half of her body weight. Then in young adult males, it's about 60%. Now, this difference results from muscle mass. Muscle mass has a little bit more water in it, and men have a higher proportion of muscle mass to body fat than women do. So, males are about 60% water, women are about 50%. Babies, they just practically leak. They're 75% water. And then the elderly, because as we age, we tend to lose muscle mass, they're down to about 45% total. Now, water is necessary for many bodily functions, and so the levels do need to be maintained appropriately. We have distribution of fluid in the body in a couple of different areas. We have intracellular fluid, that's stuff that's actually inside the cells, and that's about 2/3 of the body fluid. And then we have extracellular fluid, which are outside the cells, and that includes interstitial fluid, that is the fluid that bathes the outer surface of the cells, and then blood plasma itself. So when you look at this, this is kind of the breakdown. 40 liters of water, or thereabouts, makes up about 60% of the body weight. Of course, that's going to be higher or lower depending on your total body mass. Intracellular fluid, which is about 40% of the body weight. Interstitial fluid, which is about 80% of the extracellular fluid. And blood plasma, which is about 3 liters or 20% of the extracellular fluid. Now, there is a certain link that exists between the amount of water and the amount of salt that you have. Solutes in the body include electrolytes like sodium, potassium, and calcium ions, and a change in electrolyte balance causes water to move. Basically, water will follow salts. So if we move salts out of tissues, water is going to follow, and so forth. If we move salts into tissues, water will follow, and the tissues and cells will swell. So, alters in blood volume and blood pressure are a result, to a large extent, on alterations in the sodium, potassium, calcium ion levels. You can impair the activity of cells if you get this out of balance. Basically, if you become dehydrated, water is going to move out of the cells. The cells are going to shrink a little bit, or in the case of red blood cells, they call it crenation. But in any case, they're not going to function properly. By the same token, you can overhydrate, move water into the cells to the point where they can actually burst. Now, maintaining water balance, water intake in general needs to equal the amount of water that we put out. And there are several sources for water intake. The foods that we eat and fluids that we drink, so ingested foods and fluids. And some foods are largely water. Celery and lettuce are largely water. Some animals can get by without drinking because what they eat is so fluid filled. And then there is water that is produced from metabolic processes. Remember that water is a reactant or byproduct of a lot of metabolic processes. You can break things apart simply by adding a molecule of water, and you can put things together by taking a molecule of water out of it. So we have these metabolic processes that make water in our bodies. Now, we have a mechanism to make sure that we are keeping enough water in our system, which is a thirst mechanism, which forces us or reminds us to take in water. Now, one thing that happens when we age is that the thirst mechanism becomes less effective, less efficient, so we don't realize that we need water as readily when we get older. So it is good for the elderly to monitor their water intake a little more carefully than younger people. Younger people are just going to get thirsty and get something to drink. The elderly can get dehydrated without realizing it. So sources of water output. There is what we call insensible water loss, which is stuff, the moisture that leaves from our lungs when we breathe, the mist that you can see in the winter months when you're breathing. We lose water in perspiration, and even though you're not aware of it, you are perspiring all of the time. So you are losing a little bit of water through the surface of your skin. And then there is the amount that leaves the body through feces. Now, all of these are what we would consider insensible water losses, in that we cannot accurately measure it, we cannot sense it, but we've got a good idea of what it is. And then there's urine production itself. So metabolism in terms of developing water intake, about 10% of the water that we get in our bodies comes from metabolic processes. Foods make up about 30%, and beverages make up about 60%, or about 1,500 milliliters per day. Now, feces, the insensible stuff, feces makes about 4%, sweat about 8%, insensible loss via skin and lungs about 28%, and then urine output is around 60%. It is interesting that urine output tends to equal the input we get from beverages. So about 1,500 milliliters a day of urine production. This is where in nursing situations, they will monitor input and output, or intake and output. They will measure how much fluids a person drinks plus how much urine they produce, and those numbers should be about the same. So that is a measurement to make sure that people are getting hydrated properly. Now, maintaining water balance. Dilute urine is produced if we drink a whole lot of fluids. And the fact is that our fluid balance is more a product of how much urine we make than the fluids we drink. If we drink a lot of fluids, we're just going to pee a lot. Less urine, or concentrated urine, is produced if we are losing large amounts of water or we haven't taken in very much water. Then we will get a more concentrated urine. Proper concentration of various electrolytes has to be present for fluid production or urine production to work properly and to maintain our balance. Now, how do we do this? Well, we've got something called an osmoreceptor, or osmoreceptors actually. These are cells in the hypothalamus, and they react to variations in blood composition. They measure just how dense the blood is. They measure the fluid electrolyte balance. And then the hypothalamus releases various hormones, particularly one called antidiuretic hormone, which prevents water loss in urine. In fact, most of the hormones that we have actually prevent water loss rather than support water loss. So antidiuretic hormone prevents excessive loss of urine, blood loss in the urine. causes the kidneys to collecting ducts to reabsorb more water. So if we start to get dehydrated, we will release more antidiuretic hormone, which will cause us to retain more water. There is a condition where if this hormone isn't working properly, antidiuretic hormone, called diabetes insipidus. Diabetes, by the way, just means excessive water output. It doesn't necessarily mean that you have sugar in your urine. It's so diabetes insipidus occurs when there isn't enough antidiuretic hormone to cause you to retain fluids, and this can lead to huge outputs of dilute urine. Now, another hormone associated with water balance is aldosterone, and it regulates the sodium ion content of extracellular fluid. So sodium is the electrolyte most responsible for osmotic water flow, and aldosterone promotes reabsorption of sodium ions. Remember, this is important, that water follows salt. So aldosterone causes the kidneys to recover sodium from the filtrate. And then as the sodium is recovered from the filtrate, water will follow. There is also a mechanism called the renin-angiotensin mechanism. And there is a structure called the juxtaglomerular apparatus of renal tubules. Basically, it is a sensor at the end of the distal convoluted tubule. And when they are stimulated by low blood pressure, the enzyme renin is released into blood cells, or into the blood. The renin produces something called angiotensin II, which causes vasoconstriction of our vessels, which causes an increase in blood pressure. So it results in an increase in blood volume and blood pressure. It also, by the way, stimulates aldosterone release. I'm not going to go through this whole graphic. It's not important. So we have talked about fluid balance and electrolyte balance. We will talk in a separate little production about pH balance. We are not going to talk about that at any great length, but this takes care of a general overview of fluid and electrolyte balance.